we learn onto function. Onto function. Onto function, another name is also there, that is surjection. You can say this is surjection. Onto function or surjection or surjective function. So onto function or surjection. Okay, so this is, first of all, this is a function. F is a function from A to B or X to Y. Let F is a function. A function is called onto function. So therefore, first F has to be a function. Let F is a function from A to B. Now condition is, if for every element in B has at least one preimage in A, then F is called onto or surjective function. Okay, very clear. Or mathematically, what you can write? Is, see, this is very simple. If every element in B, this is every element in B. Okay, for function every element in A. Here, every element in B should have an image. Has at least one image, one or more images, but they should have image. Understand like that. So like this, let's write an example first. So A, this is B, and here 1, 2, 3, 4. A, B, C. Now here like this. So now just you have to check. A has preimage? Yes. 2 preimages, no problem. B has preimage? Yes. C has preimage? Yes. So A, B, C. So every element in B, that is A, B, C, every element has at least one preimage. Minimum one preimage should be there. Okay, one. So B has one preimage, C has one preimage, A has 2 preimages. That's no problem. Okay, at least one preimage must be there. So if at all I keep here, this is what is I said this is onto. But if I keep here D, what happens? If I keep here D, what happens?
Then it's not an onto function.
Why not onto? Every element should have a preimage. D element has no preimage, so therefore it's not an onto. Okay, all right. So now mathematically, how do you write? Let F maps A to B. If, okay, we write if for every Y belongs to B, there exists at least one X belongs to A, such that F of X equal to Y. That means what? Very simple. Y preimage is X. Instead of telling X is a preimage, I wrote F of X equal to Y. That's it. For every Y belongs to B, there exists at least one preimage. I didn't say here preimage. Here I wrote F of X equal to Y. F of X equal to Y means what? Image of X is Y. Under F, under function F. Image of X is Y. Or you can say preimage. Preimage of Y is X. Preimage of Y is X, yes or no?
Yes, sir.
Like this. So I gave this example. You can see. Okay?
Yes, sir.
Surjection onto. Okay? More examples. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So How do you make it injection? Now
It's
is it
injection. Yes, sir.
okay? First, injection, right? Injective function or injection, yes or no?
Yes, sir.
Two, onto function or surjection or no?
It's not an onto function.
Not on.
Not
Not onto. So now how to make it onto? How to make it onto? Can we see an image like this? Is it onto
No.
now? Why?
No,
Why?
because no two elements can have the same image.
Yes, so it loses its property to be a function. It will not be a function,
Yes,
right?
sir.
So therefore,
Yes, sir.
So here, because here B has 5 elements, A has 4 elements only. So B has 5 elements. That means what? 5 pre-images must be there. Yes, sir?
Yes, sir.
Must exist. But here only 4 elements are there. Okay? Yes, sir?
Yes, sir. Yes, sir.
So then 2 elements must have same image, then same pre-image, then that is not a function. So therefore, the conclusion is n of a, see, n of a must be greater than equal to n of 3. Yes or no? B,
Yes, sir.
number of elements in B, whatever elements are there, they should have pre-image, means what? A should have same elements are, same number of elements are more elements.
Yes, sir.
So this is the condition. Note. Okay, n of A is greater than or equal to n of B for F to be onto. F to be onto. Okay.
Yes, sir.
All right. So then we'll take next example. Let's go for next example. What is that? Now let's take a infinite function. Let's take R to R, real numbers to real numbers. F is a function from R to R defined as f of x equal to 2x plus 3. Is it onto function or not?
It is an onto function.
Is it?
Sorry, not an onto function. It is a one.
It's
One
one
function.
function. Yeah, for sure. It's one function for sure. Why
Onto,
it's,
I don't know.
why is it not on? Why is it not? How do you check? You can't write all the elements here.
Yes, sir. We can't write all.
Yeah, anyway, for your understanding, let's take this example for F maps n to n. First, let's take for n to n for your understanding. So 1, 2, 3, 4, 5. What do you think? Whether it's for n to n, f of x equal to x plus 3 is onto or not? So one image of one is what? Can you guess what is the image of one? Image of one for
5. 5.
good. Yeah, image of one is 4. 5. Image of 2 is what? 2 to the 4 plus 3 is 7.
Yes, sir.
So what is the conclusion? What can you say whether it's onto?
It isn't an onto function.
It cannot be onto.
For natural numbers, it's not onto function.
Not onto y. Not onto y. Why? Because one to image of one is not possible. One ka pre-image to exist name of the yes sir, pre-image of one.
Yes, sir.
You know what is pre-image of one? You know how do you find pre-image of one? One f of x value I should get 1. Yes sir.
Yes,
no,
sir.
f of x ka value, it's this value has to be 1 na. So f of 1, what is that? F of 1, 2 into 1 plus 3, this is 5, right? I know f of
Yes,
x,
sir.
f of x 5, 1, f of x is 5 means x value 1. If you put, then f of x, what do you have to put x value to get f of x value 1 is the question.
-1.
Yeah, exactly. So how do you find that x plus 3? 2x plus 3 is 1. 2x is minus 2, x is minus 2. See? Right?
Yes, sir. So your voice is breaking a little for me. I think it's a problem on my end only.
Now is it okay?
Yes, sir.
All right. You understand, like this you have to find out the pre-image. This is how you have to find out pre-image. Is that okay?
Yes, sir.
So now in general, how do you find a pre-image? So now I want pre-image of y. Okay, y ka pre-image hona chahiye. So let's take x is pre-image of y. See, this x, image of x is y. That means what? Pre-image of y is x. Is that okay?
Yes, sir.
So now 2x plus 3 is equal to y. That implies x equal to y minus 3 by 2. You understand? You understand it properly. Now y, if you want pre-image of 1, you get it here. Y के जगह पे 1 डाले तो 1 minus 3 by 2 is minus 1. Yes, sir? You understand?
Yes, sir.
I generalized.
Yes, sir.
Okay, like that. This is pre-image. You understand? This pre-image. So one if you
Yes,
keep,
sir.
one if you keep, you have pre-image that's minus 1. Doesn't exist in natural numbers. And if you keep 2, then it's minus 1 by 2. And x is 2. Y is minus 1 by 2. You getting this? Yes or no?
Yes, sir.
Like that. So 2 pre-image doesn't exist, 3 pre-image doesn't exist, 4 pre-image doesn't exist. Okay. This is 1-1. This is 1-1 for sure, because different elements have different images for sure. 1 image is this, 2 image is this, 3 image increase, right? Increase. Yes or no?
Yes, sir.
So different elements have for sure different images, no doubt. Every element has unique image. Okay, and different elements have different images. So 1-1 function, but it's not onto. It's not onto from end to end. Now let's check for.
Sir, I have a doubt.
Yeah.
For a function to be both 1-1 and onto, the number of elements in A should be equal to the number of elements in B, no?
Exactly. For 1-1. Yes, that's true. No. What is that? For F maps A to B. For F maps A to B. To be 1-1, condition we discussed is different elements should have different images. So n of a number of elements in A must be either equal or
So
greater.
they are equal to the number of
yes,
elements.
Yes, number of elements in A is less than or equal. Different elements should have different images. So 5 elements are there. So B must have 5 or more. And this is 1. For to be 1-1, this is a condition. So if F maps A to B is onto, what's the condition? N of A must be
Number of elements in A
to
should be greater than or equal to the number of elements in B.
from 1 and 2. If it is both 1 and 1 and onto, both 1-1
then equal both
and onto. That implies and implied. That implies N of A must be equal to N of A. Yes, you are correct. That's true. Okay, but now
yes,
let's check for onto. Onto, how do you check onto? Yes, sir. Now F maps here R2R and R2R defined as f of x equal to 2x plus 10. How do you check it's onto? Yes, it's onto. Because we are checking, let image of, how do you, image of x is y or pre-image of, okay, the image of x is y. What does it mean? F of x equal to y. That is pre-image of y is x. That x must exist where? In real numbers. Yes or no?
Yeah, sir.
Yeah. So therefore, now 2x plus 3 is y. Now x is y minus 3 by 2. What is this? You know, preimage of y. Understand?
Yes, sir.
Yes. So here, pre-image of y is y minus 3 by 2. Yes or no? Yes or no?
Yes, sir.
This belongs to R, I say. Why? Here y is a real number. Hai na? How do you check? Y is a real number. Yes or no?
Yes, sir.
That is y minus 3. Y minus 3 is also real number. Yes or no? Y
Yes,
minus
sir.
3 is real number. So y minus 3 by 2 is also real number. Yes or no?
Yes, sir.
But previously, but if f is a function from natural numbers to natural numbers, what will happen? Y is a natural number है ना, इसमें इधर से y we have taken from b, set b, इसका pre-image okay has to be here, has to be here.
Yes, sir.
So y is a real number. That implies y minus 3, there is no problem. Y minus 3 cannot be real, sorry, y is a natural number. Y minus 3 can't be a natural number. Y minus 3 by
Yes,
2,
sir.
surely not a natural number. Okay, for all
Yes, sir.
y belongs to n. So y, whatever y you take, whatever y is any natural number you take. Okay, y minus 3, y if you take simply natural number 1. Y minus 3 is not a
None.
natural number.
Then it becomes negative. It's not natural.
Yes, you understand. That is the reason this
Yes,
is not
sir.
a 1-1 function. This is not a onto function. You understand?
Yes, sir. Yes, sir.
You got this?
Yes,
Now
sir.
it's on to or not? It's on to now. F maps. So pre-image exists. Okay, pre-image exists or not?
Exists. It exists.
No, for this exists. For this exists.
For rational numbers, it exists, but not for natural numbers.
Rational numbers exist and real numbers exist.
Yes,
Okay.
sir.
So now, okay,
Yes,
you
sir.
may
Yes,
ask. Okay, now we'll take an example where it fails. Let's take an example. F maps R to R. Okay, defined as f of x equal to, simple example, x square. Is it on to? So is it on to? Yesterday we discussed not 1-1. So today we'll discuss on to unknown. Same question.
So it can't be 1-1 because negative numbers.
Yeah, different elements have the same image. Yeah, that's
same
true.
image, so it's not possible. Onto Sir, I think it is onto.
No.
No, for real numbers, it's not onto. For natural numbers, it is onto. I think. So 1 second.
So you think of the images. What are the images? F of x, all the images. X square is a real number, right? X is a real
Yes,
number,
sir.
right? X has to be taken from set here. X is any real number you take. So x square, what is x square? Is always greater than equal to 0. You understand?
Yes, sir.
That implies what, you
So
know?
that's
All the images are only non-negative.
natural.
Non-negative.
Non-negative. Yes, sir.
You understand?
So it's not 1-1. Sorry, so it's not onto.
Why?
So because real numbers in the second set, the negative numbers won't have a pre-image.
Exactly. All the images are positive means what? For negative number, there is no pre-image. Exactly. You are
Yes.
correct. You are correct. 0 लिखेंगे, here -1, here -2.
So that's why I thought it might be true for natural numbers, but that also doesn't make sense.
Yeah, that's correct. That's correct. So for -1 is a 0, 1, 2, 3, -1, -2. See, -1 image is 1, 1 also image is 1, 0 is image. So its pre-image doesn't exist only.
Yes, sir.
So here to see, here I'm going to write now definition another way. So we'll check here now. So here onto function, that f is a function from A to B. For every element in B, okay, there is at least one pre-image in A. Yes or we wrote same like this. So I'm going to add here one thing. See, same thing. Every element has at least one pre-image, right? Every element in B has at least one pre-image. Another
Yes,
way you
sir.
can say is, that means, you know, every element of B is an image. Got the point? An image of at least one element of A. Understand? Every element must be image, na? If it's image,
Yes, sir.
then only we say it has pre-images. This is image, so it has got pre-image. This is image. This is got pre-image. This is not an image of any element, therefore it doesn't have a pre-image. If it's image, then it has pre-image. Yes or no?
Yes, sir.
Yeah, that's right. Okay. All right. Okay, this is how. Or what you can say, you know, or you can say, or another way you can say is f is a function from A to B is onto, very simple. Okay, if codomain equal to range, codomain is B here, range is f of A. Codomain equal to, simply you can say codomain must be equal to range. What is range set of? What is range, you know? What is range, you know? Range
Yes,
means
sir.
what?
The set of all possible.
No, all the images. Codomain equal to range. Range means what? Range of F equal to set of all images. Set
Yes,
of all images. You call range is set of all images. Now all the images must be equal to B. That means what? All the images must be equal to B. B and set of images. That means what? All the elements have pre-image, then only say codomain equal to range. So you can tell like this. Here is first example. So here codomain is B, hai na? Codomain is B. This is not equal to range. Why? Range is ABC only.
Yes, sir. Got it.
Okay. So like this we'll take 1, 2, 3, 4. A, B, C, B. So now this is okay. Now codomain is B. Okay, codomain is B. Range is what? Range is also B, na? Total B is
Range is
range.
also B. Yes, sir.
Okay, this is on 2. Okay. So then next 1, 2, 3, 4. Here A, B, C. So what is codomain? B. Range is what? B. Yes or no? Yes or no? Every element in B is an image. Every element is image. That means what? Every element is there in range. That means what? Total B becomes range. Codomain equal to range. Simple, yes or no? Here, codomain
Yes,
is B,
sir.
not equal to range, because range is only A, B, C. So that means what? D doesn't have pre-image. Simply what you can say,
Yes,
codomain
sir.
is not equal to range. So like that, simply you can say here also, what is codomain? What is range? So range we can find it always. So codomain is, you know what? Codomain is all real numbers. range is only, you see here, x square greater than 0 to infinity. Yes or no? Range is only from 0 to
Yes, sir.
infinity. 0 to infinity. Yes sir. So that means what?
Yes, sir.
All the negative numbers. Okay. So that means what?
Are not
Simply
covered, and that's why the negative numbers don't have a pre-image.
pre-image. Yes, simple. Very simple, right? Like that.
Hmm.
Is that okay? Simple.
Yes, sir.
So
Yes, sir.
so then like that we can give an example, you know. So yeah. So I'll show you. Now, this is anyway on 2, so we are not. So how do you check this one? X is a real number like this. 2x is a real number and 2x plus 3 is real number. So range is codomain is R, range is also R. Like
Set of all real numbers.
so, but here you can't say. Okay, here 2x plus 3 for natural numbers. X is a natural number. 2x is a natural number. 2x is a natural number, but not all natural numbers. No. 2x is natural number, but 2x is what? 2x is only like this. 2x is 2, 4, 6 है ना?
Yes, sir.
Okay.
2x belongs to natural numbers, but all of them are not natural numbers.
Not all natural numbers are not there. So like that, little intelligence we have to use. Like, okay, knowledge. You understand? Now,
Yes,
injection, surjection is over. Now, bijection. Bijection or bijective function. Bijective function. Or simply you can say 1, 1 on 2. 1, 1 on 2.
So it's both 1, 1 and on 2.
1, 1 on 2 function also you can say. Such bijective function you can say, or bijection simply you can say. So what you said, f maps A to B is both 1 and both 1. Okay, so essential condition is what? Not that
Number of elements in B must be equal to
number of elements in A. Okay.
yes, sir.
This is bijective function. Okay, here comes important thing actually. Here comes very important thing. See, f is a function from A to B. For example, let's say 1, 2, 3, 4. Now you know what? Different elements in A must have different images in B.
Otherwise, it's not.
Yeah, different elements must be there. Different elements. 4 different elements must have 4 different images. And see
Yes,
what happens is now f is a function from A to B.
Yes, sir.
F inverse is what, you know, function from B to A. This may not happen for everything. F inverse exists. F is a function, then F inverse exists, but F inverse may not be a function. F inverse, okay. So you know that for every function, f maps A to B. For every function f maps A to B. For every function f maps A to B, f inverse exists. F inverse exists. What does it mean? You know, for every function f maps A to B, f inverse exists. Okay, but f inverse is a relation from B to A. Okay, and
yes,
may not be a function. You understand? You understand?
Yes, sir.
For example,
Yes, I got it.
for example, now 1, 2, 3, 4. Here A, B, C. You know, like this. Okay. You understand? F is a function from
Yes,
A to
so
B.
this is
F inverse
f inverse is not
not
a
a
function.
not a function. Good. Not a function. Why? Why not a function? Because B
one
has,
element has two images.
yes, from B to A, it's not a function, it's only called relation. But see, no. If you see, that's what we discussed in the previous one. See, F is a function from A to B, F inverse is function from B to A, F is a function from A to B, okay, and bijection. F inverse is a function from A to B and bijection. That is, F is a function from A to B, which is bijection. F is a bijective function, then F inverse is a function from B to A. Yes or no?
Yes, sir.
Okay, that's what is the next one. If F is a, F maps A to B is 1, 1 and 2, 1, 1 and on 2, then F inverse is also a function. Not only that, F inverse is also a function. F is also a function.
Yes, sir. Got it.
Also a function which is bijective.
Bijective.
That's also bijective. This is what is inverse function. So these all things I have to teach you because inverse trigonometric function. So sin x is a function. Sin x is a function from real numbers to -1, 1. You know this? Yes or no? Sin x ka image, sin x range is what you know. Sin x, sin theta range is -1 to 1. Yes or no?
Yes, sir.
Yeah, here this is x. You can put any real number. F of x and f is a function from r to -1 to 1. This is f is, if f is a sine function. You know what? F inverse exists. Inverse trigonometry, sine inverse. We have to discuss about sine inverse. That means inverse function we have to discuss. For that, you should know what is inverse function. Inverse exists only when f is 1, 1 and on 2. Got my point?
Yes, sir. Got it.
That is the reason we have to discuss this, without which you will not understand deeply. Okay.
Yes, sir.
So therefore, if f is a 1, 1 and not 2, then only f inverse exists. Got it?
Yes, sir.
So now sine function. Let's take sine function. Sine function. Let's take sine function. So I'm not writing all, but we'll write 0. Develop 5 by -5/2 -5 like the so many. Develop 5/2 5 so on. I'll write 0 -1. I'll write and then 1. I'll write 5/2. What is the image of 5/2? So we write real numbers. This is only -1 to 1 only. I'm writing. Okay, this will write also. This also will write all the numbers. Okay. Now is it a 1, 1 function? -1 का कोई image?
So it's not a 1, 1 function.
-1 का कोई image, -5/2 is -1. 3π/2 image is also -1.
-1. Yes, sir.
Sin 0 is 0. Sin 2π रहता ना? Sin 2π का image also 0.
Yes.
1, it's not 1, 1 only. Many to 1.
Yes, sir. It's many to 1.
Yeah. So like that, if all real numbers is taken, then it's not even onto. Not onto. If you
Not
take
on
all
two
real
also.
numbers.
Yes, sir.
But if you instead of this, if you take -1 to 1. Only if you take -1 to 1, that's the only range. Now, range only you take codomain. Codomain you take only range. Codomain equal range only.
Then it becomes an onto function.
Onto function. Like that. So sine inverse doesn't exist. Further, we have to do some repair work. Only we have to take, we have to restrict this domain. We have to restrict domain. We have to restrict from what -1 to 1. So that is minus pi by 2 to pi by 2 only we should take. You understand? Minus
Yes,
1
sir.
to 1 only. -1 to 1 only. That much only we should take. So then only inverse exists.
Yes, sir.
Yeah, like that.
Got it.
Like that, we have to discuss that. After finishing this, you will find more meaningful and more interesting. Okay.
Yes, sir.